Oh, good evening, YouTube viewers. My topic for tonight, I will now be on lesson number 9. Lesson number 9 on integral calculus. Lesson number 9, this will now be a topic on the integration of exponential functions. Integration of exponential functions. Okay, under exponential functions, that there are only two integration formulas. So I will now give you the two formulas for integrating exponential functions. Exponential, the first one is if the base is e. The value of e is actually the one we derive in integral calculus, that is 2.7181828. And the other exponential thing is that if the base is not equal to e, it is simply a, where a is a constant not equal to that first e. This should be the second one. Okay, I will give you the first integration formula. The integral of e to the u du equal to e to the u plus c. That's the first one. Later on, I will give you the derivation of that. How come the integral of this is this? Okay? Number 2, the integral of a. A is a constant not equal to e, okay? Raised to u du equal to a to the u all over the natural logarithm of a of that base plus c. That's the second formula. Okay, I will now give you the derivation of this. So memorize these two formulas here by heart. Okay? Because to integrate exponential functions under integrals, you should memorize this by heart. The integral of e to the u du is e to the u plus c. The integral of a raised to u du is equal to a raised to u all over natural logarithm of a plus c. Let's bring out the derivation. For this number 1 formula, we let y equal to e to the u. Okay? Take the differential of both sides. The differential of y equal to the differential of e to the u. Whatever you will do on the left, do it on the right. Okay? The differential of y is just dy. And the differential of e to the u, use your knowledge of differentiating e to the u under differential calculus. It is simply e to the u times du. That is from differential calculus, right? That is one of the formulas under the so-called differentiating exponential function under differential calculus. The differential of this, okay, is just simply e to the u times du. Okay? Take the integral of both sides. The integral of the differential of y equal to the integral of e to the u du. Then try to rearrange. Put this on the right, put this on the left. No, put this on the left, put this on the right. The integral of e to the u du now equal to the integral of dy. Or the integral of e to the u du, as I told you before, if this integral sign goes this differential sign, they will cancel out each other. Okay? So the integral of the differential of y is just y. Okay? Since we are integrating indefinite integrals, this is plus c. But what is y? What is y? Y is e to the u. So the final answer will be the integral of e to the u du is y. But what is y? It is e to the u plus c. Okay? That's formula number 1. Memorize that part. If you know how to differentiate e to the u, you should know also how to integrate. And the formula for taking the integral of e to the u is just simply e to the u plus c. Okay? Don't forget that one. That's formula number 1 under exponential functions. Number 2, the derivation of this. We let y equal to a raised to u. Take the differential of both sides. The differential of y equal to the differential of a to the u. The differential of y is just dy, and the differential of a to the u, recall your formula on how to take the differential or derivative of a to the u. It is a to the u times the natural logarithm of a times the u. That's differential calculus, right? Then take the integral of both sides. The integral of dy equal to the integral of a to the u, natural logarithm of a times the u. Okay? This a here is a constant. So the natural logarithm of a is a constant. And whenever we are integrating, if there is a constant inside, you try to bring it out. So we put this one on the left, then we bring out natural logarithm of a. So natural logarithm of a now, we bring it out. The integral of a to the u du equal to the integral of dy. As I told you before, when this integral comes this differential, they will try to cancel out each other, right? So natural logarithm of a, the integral of a to the u du is just equal to y. Okay? Then try to divide both sides by the natural logarithm of a. Okay? On the right hand side, natural logarithm of a cancels. Okay? So y times 1 over natural logarithm of a is 1 over natural logarithm of a times y. But what is y? Y is e to the u. It is e to the u. This is plus c. So the final general formula on how to take the integral of a to the u du is a to the u all over the natural logarithm of a plus c. Memorize this by heart. That's actually formula number 2. Formula number 2, this is. Right? You got it? Okay. Let's try to bring out examples. It's easy to memorize these two formulas. E to the u plus c, e to the u over natural logarithm of a plus c. Example number 1, we are given the integral of e to the 5x dx. It is under formula number 1. The value of u is the exponent of e. So we let u to be 5x. Du will be 5 dx. It is not exact. We are missing 5 inside. Okay, so we insert 5 inside. And to offset this one, okay, we will place 1/5 outside. Because actually 5 and 5 cancels. It seems it is the original problem, right? But to bring out the answer, you must have to place 1 over 5 outside. So the final answer will be 1 over 5 e to the 5x plus c. That's the answer. It's easy. Easy money. Right? This is e to the u, and this is the complete exact value of the u from our verification. That's why we place 1 over 5 outside to counter this one. The final answer, I will repeat it for the last time, 1 over 5 e to the 5x plus c. Easy. Okay? Example number 2, it's the same. Same as using the first equation, only that the exponent is negative. The integral of e to the minus 2x dx. It falls under formula number 1. Okay? the value of u is minus 2x, du is minus 2 dx. It is not exact. We are missing the number negative 2 over here. So we will place negative 1/2 outside. Okay? Negative will be plus, so it should be negative because there's a negative inside. Right? So upon placing negative 1/2, the integral of this one now falls under formula number 1. So it should be negative 1/2 e to the minus 2x plus c. That's the final answer. The only work you need to do is to verify the complete value of du. If it is missing some constant, counter that constant by taking the reciprocal. Okay? It's easy. Example number 3. The integral of dx over e to the x equal to. For the meantime, this e to the x is at the bottom, right? So in order for this one to fall under formula number 1, we must have to transfer this e to the x to the numerator. And the correct way of doing that is to multiply the given term by e to the minus x over e to the minus x, because this is actually 1. Right? dx times e to the minus x is e to the minus x dx. E to the x times e to the minus x, same base, add the exponent. So it should be e raised to x minus x. X minus x is 0. And e to the 0 is 1. Any number raised to the 0 power except 0 is 1. So actually this is now 1. This is 1. Or just simply the integral of e to the minus x dx. And if you try to inspect this one, it falls under formula number 1. The value of u is minus x, the value of du is minus dx. It is negative, but what is given is positive. So to bring out the answer, you place negative 1 outside, but maintain the negative inside. So this is open quantity, negative 1 closed quantity, the integral of e to the minus x times dx. This is under the integral of e to the u du. Okay? So it will just be simply negative e raised to the minus x plus c. Or to avoid the negative exponent, bring it down. Okay? The final answer will be negative 1 over e to the x plus c. That's the final answer. It's easy. Right? Example number 4. The integral of 4 raised to x times dx equal to. Obviously, it is not under formula number 1 because the base is not e. It is a number other than e, and that number is 4. So we let u to be equal to x, du is equal to dx. Okay, it is exact. Therefore, the integral of 4 to the x dx equal to, similar to the integral of formula number 2, the integral of a to the u du. And as we derive it, the integration formula, the formula on how to integrate that one is a to the u, natural logarithm of a plus c. Substituting now, this should now be 4 to the x over the natural logarithm of 4 plus c. As simple as that one. Okay? Let's try to bring out the final example for tonight. I give you examples that are a little bit easy, so when you go to the complicated ones, at least you can try to scramble your mind on how to solve it, right? But I could give you more complicated ones if you want. Example number 5. The integral of e to the cosine of x, sine of x dx. This falls still under formula number 1. The only thing is the value of u is trigonometric function. So the value of u is cosine of x. Take the differential of both sides. Du, the differential of cosine is negative sine times dx. The derivative or differential of a cosine is negative sine. Okay, so this is minus sine of x dx. Is it exact? It is not exact, because there is a negative sign over here. this is plus, right? So to bring out the answer, put a negative 1 outside, but maintain the negative 1 inside. Because negative is still a positive. Still, it's the original problem, right? But to bring out the answer, you must have to place negative 1 outside. So upon placing negative 1 outside, this now falls under the integral of e to the u du. Okay? And this should be equal to negative 1 times e to the cosine of x. This is preceded by negative sign. Negative e to the cosine of x plus c. That's the final answer. The only complication is that for each of the u here, they are not the same. And here, the u is trigonometric. The remaining examples from 1 to 4, the value of u is algebraic. I think that's just more than good enough for integration of exponential functions. So if you like it, please click like. If you want to share it, click share. And if you want to subscribe to my channel, please click subscribe. Good evening, YouTube viewers. Thank you.